Now, after looking at those simulations from GeoGebra, let's look at another illustration here. So, two solids are being compared in this illustration. You have a pyramid and this is the prism. So, notice that the pyramid and the prism have the same height as described by the variable h, right? But when it comes to volume, when the pyramid is filled with sand and poured into the prism, it takes 3 pyramids to fill the entire prism. So that also explains how the volume of a pyramid is related to the volume of a prism, given that they both have the same height, such as in this figure. So to summarize what we learned about the simulations from GeoGebra, recall that for a prism, the volume is given by base area times the height of the prism, right? And same is true for a cylinder. A cylinder is like a prism with a circular base. But since we saw that, a prism can be broken down into 3 pyramids of the same volume, the pyramid formula for volume will be 1/3 times the base area times the height of the pyramid. And that is true for right pyramids and for oblique pyramids as well. So let's use this example to illustrate how to use the formula. In this case, the base is a triangle, right? So for the base, we need 1/2 times the base of the triangle times the height of the triangle, which is equal to 1/2, the base is 4, and the height is 6. So if we simplify that further, 24 divided by 2 is 12 meters squared. So that's for the base area only. If you want to find the volume of the pyramid, we get 1/3 times the base area, which we have gotten already, times the height of the pyramid. So B is equal to 1/3 times 12, and then the height of your pyramid is 9. So this will be equal to 12 divided by 3, that's 4 times 9, so that's 36 cubic meters. So the volume of the pyramid is 36 cubic meters. Let's do another example. So we have here a square pyramid. So why is it square pyramid? Because the base is a square. How do we know that it's a square? Well, all the sides are equal because they have same tick marks, and you have this square symbol here. I mean, the right angle symbol. So that means all the corners are right. So for the base, since it's a square, we multiply 10 by itself, so we get 100 centimeters squared. Now to find the volume of the pyramid, we're going to multiply the base area times the height of the pyramid and then divide it by 3. So this will become 1/3 times 100, and then the height of the pyramid is 12. So 12 divided by 3, that's 4 times 100, so this will become 400 cubic centimeters. Now for the second one, what do we have here? How many sides at the bottom? 1, 2, 3, 4, 5, 6. So that's a hexagon. So this is an example of a hexagonal pyramid. Okay, so since the base is a regular polygon, okay, so for the base, we will use the formula 1/2 apothem times perimeter to find its area, right? Well, we don't know how long the apothem is. We just know that we can form it by drawing a segment from the center perpendicular to one of its sides. And then if you draw the radius, we can draw it from the center to one of the vertices. So since this is 12, the whole thing is 12, let me separate that right triangle over here. Okay, so since one side of the regular hexagon is 12, then this side is 6. This is the apothem that we're looking for. So we need to find a way so we can solve this triangle for this angle here. So how do we find this angle? So this angle is actually 360 divided by 6 because it's 6 sides. So one central angle is 60 degrees. So we need to get 1/2 of that, right? So now let's get 60 and then divided by 2. So that's going to be 30. So this angle here is 30 degrees. And by using one of the properties of a 30, 60, 90 triangle, which is longer leg is equal to radical 3 times the short leg, the longer leg being your apothem and your short leg being 6, right? So your apothem is 6 radical 3. So to find the base area, you get 1/2. The apothem is 6 radical 3. And one side of the hexagon is 12. So if you multiply 12 by 6, you're going to get 72. So this will be equal to 6 divided by 3. 6 divided by 2, that's 3. So 3 multiplied by 72 will be 216 radical 3. So this is for the base area only. So now using the formula for volume, which is 1/3 base area times the pyramid height, we have 1/3 216 radical 3 times the height of the prism is 20. So if you calculate that, it will be, correct me if I'm wrong, it should be 1,440 radical 3 cubic centimeters. So that's the volume of this hexagonal pyramid here. So rounding that off to the nearest tenth, this will become 2,494.2 cubic centimeters.